Okay, so the first part of this, actually the first two parts are basically the same thing. When will the sample size be large enough, and when would it not be large enough? Well, since the smaller of the two sample sizes is 50, in fact they're both 50 in this case, we're going to use 50 as our value for sample size, which means that we're okay as long as there are no extreme values. So when would it be large enough? It's large enough as long as there are no extreme values. Outliers and skew are okay. When would the sample size not be large enough? Anytime there was an outlier. The hypotheses, the null and research or alternative hypotheses, it says, can we conclude that there's a difference between the two population means? Of course, the null hypothesis will be that the two population means are the same, equal, and the alternative will be mu A not equal to mu B. I'm going to go ahead and remind you here that it's worth noting, I think, that mu A minus mu B equal to 0 is an alternative way to state the null hypothesis. Okay, to construct a 95% confidence interval, we'll just plug all of our numbers into the calculator. Stat, turn it on, stat, test, 2-sample t interval. And so now I've just put in the mean, standard deviation, and sample size for the first group, and then the mean, standard deviation, and sample size for the second group. Confidence level 95. And it says here, do not pool the variances, so we select no on that and hit calculate. And so our confidence interval is about 2959 to 9041. 9040.99041. Our hypotheses were that they were equal or not equal. We'll reject HO. They're not the same. 0 is not in the interval. In fact, the entire interval is quite a bit above 0. Starts at 2959. Okay, the effect size, actually this one in this case is a little bit, well, we're just going to fudge on a little bit. There are some actually rather complicated formulas that we could use for this. As you've seen when we're using JASP, of course, when we get a very large sample, it's not going to make any difference whether you use the pooled or the unpooled thing. So what we're going to do is when we compute the effect size, we're going to go ahead and use the pooled, simply because when we use pooling, our calculators, our TI calculators, give us a standard deviation, a pooled standard deviation that we can use for effect size. Before I do that, on the numerator, the size of the effect will just be the difference between the two sample proportions. In other words, we have 88,924 and 82,924 that differ by 6,000. So that's going to be the numerator of the effect size. We could subtract the hypothesized parameter from that, but that would be 0 in all cases. So it'll just be the difference between the two sample means. So I'm going to go stat now, and really doesn't make any difference if I do an interval or a test, except for I have to do a t, whichever one I do. The numbers are all in there. I do have to pool to get that. The only reason I'm pooling is to get the pooled standard deviation. And you can get that right here. This XXP is the standard deviation. It's pooled standard deviation for the two groups. 7649. So to get the effect size, we will take that difference between two sample means, divide by the pooled standard deviation, and get 0.78, which would be using Cohen's guides for exploratory research. Remember 0.2, 0.5, and 0.8. This is in the medium range.